If you weren't here last time, basically the general gist of volumes is, do you know how like for area under a curve, you integrate the height, right? Are you with you? Do you remember that? For area, you just integrate height. And then, so for volume, it's the integral of area. So if you just remember that volume is the integral of area, then all of this section will be pretty easy to you. You just need to find the area of one cross section. So it goes the same backwards. So like the derivative of volume is area, like surface area, and the derivative of area would be, I don't know, I guess height. Okay. All right. So we did cross sections last time where we integrated the area and we built basically shapes on top of a flat surface. We built like rectangles and circles and semicircles and stuff. This time, instead of building shapes on top of a flat object, we're going to take a shaded region, like for example, this is our shaded region right here. And then we're going to revolve that shaded region around an axis. Sometimes the axis is going to line up flat with the shaded region, and then sometimes the axis will be off of the shaded region a little bit, okay? We're going to start with the shaded region being straight flat to the axis. We call this the axis of revolution. So if I take this shaded region and I revolve it around this line, basically I take that shape and then I revolve it around that line, it will make this type of funnily looking thing. All right. There's two ways you can revolve a region. The first way to revolve a region is if you have a horizontal axis of revolution, it would revolve this way over your axis of revolution. And then you would make a, sometimes if you really want to see it, it would like be a reflection down here. And you would make, I don't know, this looks like an orange, like if you sliced an orange in half. Okay. Or you can have a vertical axis of revolution. If you have a vertical axis of revolution, we're revolving around this line. Okay, so if you're revolving around that line, then this shape is gonna be a reflection here. And then our region will be different. It's gonna look different if you revolve it around vertically than when you revolve it around horizontally. So don't necessarily, you can't just do one and do that all the time. You have to know which axis you're revolving around. Okay? All right. Volume is the integral of area. If I took one slice of this shape, what does one slice look like? A circle, right? One cross-sectional slice, a cross-sectional slice. If I took one slice of this, we would have a circle, right? So for this one slice would be a circle. Okay. And if I want to find area of this cross-section, and I know the distance from here to here, that's my what? Radius, right? My radius right there. So area of one cross-section would be pi radius squared. So that's why when you want to find volume, you integrate the cross-section of pi r squared, because one cross-section is a circle. Okay, this one is the same thing, but you're revolving it horizontally, so your radius will be this distance. So you're going to go from right to left instead for this one, instead of top to bottom. Okay, so it's not like the semicircle like we did last class. It's revolution. So instead of having the diameter, we're having a radius. Okay, got it? Let's do a problem. Okay, find the volume of the solid of revolution obtained by revolving the plane region bounded by y equals square root x. So this is y equals square root x. The x-axis, so this is my axis of revolution, because we're revolving it about the x-axis, okay? And then we're stopping it at the line x equals 4, so we're stopping it here. So my shaded region is this little part right here. And my shaded region sits flat on my axis of revolution. So since it sits flat on my axis of revolution, I've got a little disk here. I'll show you a little picture. So that's 4. All right. And our axis of revolution sits on the x-axis. So you revolve one little rectangle and then you add them all up together and it creates a ham. It looks like a ham. No?
Why not a wedding cake on its side?
Okay, but yeah, true. But I want to make the distance, the layers of my wedding cake, I want to be super small. Actually, I should do this one. So we're going to go from 0 to 4. Axis of revolution on the x-axis. So the more slices you have, the more exact your area. So it makes that kind of shape. You kind of see it? Yes? Right? Okay. I don't know. Tip of a ballpoint pen. Okay. So it makes that shape. If you want to draw it yourself, if you don't have a graph and you want to draw it yourself, the best way to draw it is to draw a reflection of your shaded region across the axis of revolution. Like a little reflection down here. And then you can draw a little circle in the middle. And then you know what your cross section will be. Okay? So, just like when we did area of cross section or volume of cross sections, we start with the area equation, which is pi r squared, right? My r this time is from here to here, right? Top to bottom. That's my r. So if that's my r, then my top curve is root x, yep. And my bottom curve is 0. And then squared. Okay? So if that's my area equation, then volume is, I like to leave the pi out. All we have to do is integrate it. And we have our shaded region begins at 0. And our shaded region ends at 4. So we're going to integrate from 0 to 4. Okay, this one's easy to do by hand, so I'm just going to go ahead and do it. Pi times x squared over 2 from 0 to 4. So it's 8 pi. And then 0 plugged in is 0. So 8 pi is our answer. Okay. Any questions? Gabe.
Is this like discs and washers, or are those like different, or is it just
Yes, discs are the circles. So they have no opening in the middle, but we're going to do a washer which ends up looking like a donut. They have a little mini circle in the middle. Okay. All right, let's do another disc just to make sure that we get how to do discs. So for the next one, we have y equals x cubed, which is this. Okay, that's y equals x cubed. The line, the y-axis, and the line y equals 3, and we're rotating it around the y-axis this time. So this one is a vertical rotation because we're rotating it around the y-axis. So this is my shaded region because we're going up to 3. And that's my shaded region right there. And see how it sits flat up against the axis of revolution? So because it sits flat up against the axis of revolution, I've got another disc. So if you want to draw the shape of your disc, you just do a mirror image of your shaded region on the other side. And then draw a little circle in the middle because we've got a disc. Okay. This right here will be our radius, our R. Okay. So this time, since our R is going horizontal, our cross-section is still a circle, so our area is still pi r squared. Our cross-section is still a circle. But since I have to go from right to left, instead of y equals x cubed, I need to do everything in terms of y because everything is horizontal now. So I need to make this x equals cube root of y. Okay, so this is x equals cube root of y. And then that's the right side of my r. What's on the left side? Just the number 0. So this will be pi. The right side is cube root of y. The left side is 0. And then squared. I guess this is not too bad to integrate, so I'll just do this by hand. Pi integral y to the 2/3. And then these two bounds, since all of my integral is in terms of y, these two values right here, just like for u sub, these need to be y values. So where our y value is 0 is our first y value, and then the end of our shaded region is 3 for our y value. So we're going to integrate from 0 to 3. So pi y to the 5/3, 3/5 from 0 to 3. So this is kind of ugly. Three-fifths pi times 3 to the 5/3, and 0 plugged in is 0, so that's it. Okay, have any questions? Do you need me to show you a visual of this one? So I'll show you a visual just in case. Going from 0 up to 3, right? Axis of revolution is the y-axis. So then you revolve it. And that's what the shape ends up making. Okay? Any questions? Not too bad, right? Pretty easy. Okay, let's go on and talk about this one. Find the volume of the solid generated by revolving the first quadrant bounded by y equals 4 minus x squared. Okay, so this one I did not give you a graph, so you're going to want to draw a little. Pick 4 minus x squared is up 4. Parabola facing down, right? But I just need the first quadrant. So the first quadrant is this part. Okay. And then for the first one, I'm revolving it around the x-axis. So here's my x-axis. Okay. And since I'm revolving it around there, does my shaded region sit flat to the x-axis? Looks like it does. So all I need to do is draw this shaded region down here as like a copy, as a reflection. And then you draw a little circle in the middle, and there's your cross section right there. That looks kind of gross, but whatever. I don't know. It's as good as it gets. I can't make it any better. I'm just going to end up making it worse. Is that better? Maybe a little bit. Whatever. Be quiet. Okay, so this is a disc. So here's my little radius right here, my little r. So if I'm revolving around the x-axis, let's go with area equals pi r squared. And my r is top to bottom 4 minus x squared, and then the bottom is the x-axis, so 0 squared. Okay. And so volume would just be pi integral. Where am I going? From 0 up to, because these are x values. Where does it intersect the x-axis? At 2, I think, right? 0 to 2. So 4 minus x squared squared. You can use your calculator for this one because otherwise you have to expand that quadratic. So I'll plug in 4 minus x squared into y1 so that I can just do pi integral 0 to y1 squared dx. I got 53.616. If you like to, you can do this without the pi and then say that it's 256 over 15 pi, but then don't forget to put the pi next to it if you are feeling like you need the accuracy. Are you with me? Any questions? Cool. Now if I'm revolving it around the y-axis, same region, but this time it goes and it makes a carbon copy on this side because I'm revolving around this line. So our slices will be, our cross-section will be horizontal, and our R will be from here to here instead. Okay. So it will look completely different. A smaller version. Okay, so area of this cross section is still going to be pi r squared. But this time our r, I have to go right minus left, so I have to solve this for x. So if I solve for x, then I get square root 4 minus y. So I'll go square root 4 minus y to 0, because this left side is 0, quantity squared. And then I will use my calculator for that. But I'll just do the integral. Oh, sorry, I didn't even write my integral. Volume will equal pi integral 4 minus y dy. These have to be y values, so I've got to go from 0 to 4 on this one. So this one ends up being 8 pi. Okay. Do you guys have any questions on disks? No? Very quiet.
Yeah. Well,
Maybe.
got someone missing.
Yeah. A couple people missing. Josh is out too. Oh, and Andrew. Mr. Basin. Andrew's not here. Okay, everybody good? So that's discs. Now, this is what Gabe was talking about, is like, are discs and washers the same thing? And this right now is washers. Ends up having like a little hole in the middle, like a donut. Because you know, like the washers, have you ever put together a piece of IKEA furniture? And then they have the little washers.
How do you make it like a hexagon instead of a circle?
Yeah, you just have to do the area with like your cross section will be you have to use the hexagonal equation for the cross section instead of a circle, right? But for this one, now we have a little open middle part. We've got a little cutout right in the middle. So to find the area of a washer, or like a donut, first we want to find the area of the big thing, which is, we're going to call this, especially with, since it's the bigger circle, we're going to call this big R. Okay, so this is pi big R squared, right? And then you're going to find the area of the little circle, and we'll call that little r. And so that's pi little r squared, right? Are you with me? And if you want to find the area of the washer, then what do? Yeah, you subtract them. Find the area of the big minus the area of the small, and then you get the area of the little washer. So you can leave the pi out since it's in the both terms. So pi big R squared minus little r squared. All right, so we're gonna integrate this when we want to find volume. So that's these two equations that you see here. Pi big R squared minus little r squared, pi big R squared minus little r squared. Depends on whether you're rotating horizontally or whether you're rotating vertically, where you want to do dx or dy. Okay? All right, example uno. Find the volume of the solid generated by revolving the region bounded by these two parabolas about the x-axis. Okay, so here's my shaded region. And a lot of people are like, how do I know when I do a disc or when I do a washer? This is how you figure it out. You have your shaded region, and then you draw your axis of revolution. And put your points of intersection right here and right here. If anywhere in this interval I don't lay flat with my curve or my axis of revolution, I've got to do a washer, because right here I've got all this open white space right in between. All that open white space is going to be the inside of your washer. So we need to get rid of that little part right here. Okay, these both sat flat against the axis of revolution. So we don't need to do a washer for that one. But this one doesn't sit flat. There's all this little open space right here. Okay, so here's how you do it. You go from the top curve and draw it straight down to your axis of revolution. That's going to be the most outside curve to your axis of revolution. That's going to be your big R. That's going to be your outer part of your washer. Okay, and then you draw from the inside curve to your axis of revolution. That's going to be your little r. Okay, so when you revolve and we find area of a washer is going to be pi times big R squared minus little r squared. This is where most people have the most problems, because they try to square both together, but you can't square them both together. That if you do them both together, you're making a disc, not a washer. Okay, so this will equal pi. Now, my big R is going to be from top to bottom. My top curve is root 8x, yeah. And my bottom curve is 0. So that's big R, and then I square it separately. My little r goes from the inside curve, x squared, to the x-axis, so 0. And then squared. Okay? And then volume is that, the integral of that. And we're going to go from 0, and then our ending point is at 2, it looks like, in terms of x. Okay, I like to go ahead and plug the big R in y1 and the little r in y2. That way, when I do my integral, I can make sure to do them both separately. So I get 9.6, so we get 9.6 pi. Okay. All right, last one that I have an example that I want you guys to do on the next page, and then we'll be done for today. The semicircle region here is x equals root 4 minus y squared. That gives you the whole curve, because it's the whole right hand side. and the y-axis. So my shaded region is right here. Now, that is being revolved around the line x equals -1. So this line right here. All right, so looking at the graph, here's my axis of revolution. Does my shaded region touch perfectly on my axis of revolution? No, there's all this little white space in between, right? If there's white space in between, that's when I know I need to do a washer. Okay, so I know I've got a washer, and then we've got to go from outside of shaded region to axis of revolution, and then inside of shaded region to axis of revolution. So I'm going to make that my little r, and this is my big R. Okay. So, area equation, pi. Now I got to do my big R. So my big R is right minus left. Root 4 minus y squared. And then my left value is not 0. It's at, where is it at? It's at -1. So it's root 4 minus y squared minus -1 squared. That's my big R. And then my little r is from 0 to -1. And then I square that. Okay. If you're doing free response and you have an equation that's as crazy as this, I would stop here, and if you want to do volume, I would just do integral area in terms of y, and then just say what your bounds are, because you have the area equation, maybe not area, just a, because that's what I would define it as. You have the area equation already defined up here, so you don't need to write it again. Our bounds will be from -2 to 2, because those are y values. And then in my calculator, I would plug these into the big R into y1 and the little r into y2. Use x instead of y. So that goes in y1. I'm showing you the total, like, if you didn't simplify anything, you could totally do it like this. Okay? And that's in y2. And now if you've already done the big R squared minus little r squared, we just need to change the bounds to -2 to 2. Might get a, nope, can't get a fraction. It's just 23.233. Don't forget to add your pi in. If you think that you're going to forget to add your pi in, put it in front of your integral. Okay. So that's how you do washers. On the next page is what I want you to try. You have, I'm going to graph the thing for you. We've got the first quadrant region of y squared equals x. So that's this. The x-axis and x equals 4. Okay? So right here, that's your shaded region. And I want you to take that region and I want you to find the volume when revolved around 4 things: the x-axis, the y-axis, the line x equals 6, and the line y equals 2. If you can do those 4 problems, then you have a good handle on discs and washers. Okay. All right, so take a minute and finish those 4. And then after you finish those 4, we'll be done for today.